The experiment is to verify the laws of combination parallel of resistances using a meter bridge. So again, before starting to provide you the details with respect to the experiment, we would like to just ask you to close your eyes, pay the full attention onto the audio and listen to it carefully and visualize the entire setup and the list of the instruments and the steps so that you can recall the complete setup details, steps to perform it, the list of instruments required to create the setup during your examination. And this is the best strategy. You can use it and you can apply it in all your subjects, theory and practical. Let's begin. So again, we'll provide you the list of the instruments which we will be requiring to start the experiment. We need a meter bridge, we need a galvanometer, we need the known resistance box, we need a one-way key, we need a battery, we need connecting wires, we need two resistors and a jockey. Let us begin with the circuit setup for this experiment. Again, here also you will be using the same circuit diagram as the first level or first steps to perform this experiment at what you did in the first experiment of the meter bridge. Let's begin with that. So place your meter bridge on the table, mark your points. The starting point where you are seeing the 0 centimeter on the scale, put that point and label it as A. The point where you are seeing the number 100 centimeter, mark that point as C. On top of it, you will be seeing 5 points. So one of the middle point, you can mark it as B. Mark the points which are onto the right side of the B as D and E, left side of the B as F and G. So in a similar way, we'll begin with the setup creation. Connect your positive terminal of the battery with the point A on the meter bridge. The negative terminal of the battery, you can connect it to one point of the key, one-way key. The other end of the one-way key, you can connect it to the point C of the meter bridge. Connect the point B to the positive terminal of the galvanometer. The negative terminal of the galvanometer, you can connect it to the jockey. Now place your known resistance box between the points F and G. Connect them there. As you can see, there are 2 points on the known resistance box. So you can connect it, one point to the point F of the meter bridge and the other point of the known resistance box to the point G on the meter bridge. Now since we are going to use here two resistances and we need to first know what is the resistance value of these resistors. So we'll use the same basic principle what we did in the first experiment, and we'll put the first resistor, let's say name it as R1, between the 2 points D and E. You can just directly connect it there using the connecting wires, and all the other connections of this setup will be done using the connecting wires. So you will be requiring a lot of connecting wires. So this is how you will prepare your setup. Now once your setup is done, we will ensure that your setup is correct. So to validate your setup, what you can do is, let's remove 2 ohm resistance from the known resistance box. Ensure rest of all the resistance keys on the resistance box are tightened. Plug in your one-way key so that your circuit is complete. Now place the jockey gently onto the leftmost corner of the wire on the meter bridge and check the deflection on the galvanometer. That should go onto the rightmost corner on the galvanometer. Lift the jockey, place it onto the rightmost corner of the wire on the meter bridge and see the deflection on the galvanometer. That should be towards the leftmost corner on the galvanometer. If you are able to see this, your setup is accurate and you are good to go. So again here we will be using the same steps to find out the resistance for the two resistors which we have, resistor R1 and resistor R2 separately. So in the first step, we will be connecting only resistor R1 between the points D and E, and we'll repeat the steps here. So again, here also we'll take another, let's say around 2 to 3 readings and we'll calculate the resistance against those values. So let's begin with the steps. So let's suppose we want to take out 1 ohm resistance from the known resistance box. So plug in your 2 ohm resistance key back and remove only 1 ohm resistance, and ensure rest of all the other keys on the resistance box are tightened. Now move your jockey gently over the wire in such a way that you get null deflection on the galvanometer, which means you should be seeing the needle on the galvanometer at the 0 point. As we have already mentioned in the first experiment, we are repeating it here that your null deflection will always happen between 40 to 60 centimeter range on the meter bridge. So try to move gently your jockey between that range on the meter bridge and note down the point. So that will be the length at which you are able to see the zero deflection or null deflection on the galvanometer when we remove or when we have 1 ohm resistance in our network. So using that value, we will be calculating further in the table the resistance of the R1 using the formula. Repeat these same steps for, let's say, values as 2 ohm, 3 ohm and 4 ohm. So what you have to do every time, you will be putting the 1 ohm resistance, remove only 2 ohm resistance. In the next step, you will put back the 3 ohm, 2 ohm and you will remove the 3 ohm. Similarly, you can continue for other values. Once you are done with this, what you can do is, first of all, remove the one-way key. Now remove the resistor R1 and connect only R2 resistor at the point D and E. And repeat the same steps what we did for R1 and create the table for R2 also for various values of known resistance. So as we have already taken 1, 2, 3, 4, you can use the similar values and find the resistance for R2 as well. Now in the previous steps, we have found out the resistance for the R1 and R2 by putting them separately in the network. Now what we will be doing is, as this experiment is for combination of resistance when they are connected in parallel. So what we will be doing is, we will remove R2 and now we will plug R1 and R2 in parallel together to the points D and E. Right? So I will be showing you in the subsequent slide that how to connect it. So you will be using the connecting wires and connect the two ends of both the resistors with the separate connecting wires and plug in both the wires of the two resistors to the point D and E so that they are in parallel. So you have to ensure that the resistors are connected in parallel. Now once your setup is created, you can validate your setup. So here also what you can do is remove only 2 ohm resistance from the known resistance box and tighten rest of the other keys on the known resistance box. Plug in the one-way key. Now place the jockey on the leftmost corner of the wire on the meter bridge. Check the deflection on the galvanometer. It should be towards the rightmost end of the galvanometer. Lift the jockey, place it onto the rightmost corner of the wire. You should see the deflection on the galvanometer towards the leftmost corner of the galvanometer. This will ensure that your setup is accurate. Steps to perform the experiments now. So now we have connected the two resistors in parallel and then finally connecting it to the meter bridge. So we'll follow the same steps again. Over here is that we'll remove some quantity of the resistance from the known resistance box. So let's begin with that. Let's Say if we remove 1 ohm resistance, plug in the one-way key so that your circuit is complete. Ensure that rest of all the keys on the resistance box are tightened so that there is no loose end over there. Now place the jockey on the wire over the meter bridge so that you can find the null deflection point on the galvanometer. As we have already mentioned, null deflection means that we should be seeing the needle of the galvanometer at 0. Again, here also you will be finding the null deflection when you place the jockey between the range of 40 to 60 centimeter. So take the reading, put it in the table and perform the experiment for say about 2-3 more readings of the resistance value. Let's say 2 ohm, 3 ohm, 4 ohms. Ensure that every time you are removing the correct quantity of the resistance. So after you have performed all these things, we will see how to calculate the resistance using the formula as mentioned in the table. So this will be your table where you will be putting your readings and you will be using the formula to calculate the resistance. So it is similar as we have done it in the first experiment. So you will be mentioning here, as the table says, we are taking 5 values for the resistance R1. Similarly, 5 values for resistance R2. 5 values when we have connected the R1 and R2 in parallel. And you'll be mentioning the amount of resistance which you take out from the resistance box, the length of the wire at which you got the null deflection, the remaining length of the wire, that is nothing but 100 minus L, and then finally you will be calculating the resistance using the formula of 100 minus L divided by L into the resistance value. After getting these 5 values, find the mean of it and you will be knowing the resistance of the R1 wire. Similarly, you will perform the same calculations for resistance R2 and resistance RP. We have just named it as we have connected R1 and R2 in parallel. So these will be the mean values. So this will be the experimental values for the resistance when the 2 wires are connected in parallel. We have got the experimental values of the resistance. Let's validate by calculating theoretically the resistance value when the 2 resistors are connected in parallel. We know the values for resistor 1 and resistor 2 as we have already done the experiment and found the mean value of it. So the formula to calculate theoretically the resistance for the 2 wires when connected in parallel is nothing but you have to take the product, that is nothing but the multiplication product of the 2 wires resistance, that is R1 and into R2, and divide that after adding resistance R1 and R2. So the value what you will be getting after doing the calculation using this formula should be matching with the value what we got it through our experiment, and hence you should be more confident that you have performed the experiment in a correct way. We are sharing some of the important points which you should remember when you are performing this experiment so that you don't go wrong in any step. So some of those important points are that always validate your setup after setting up the entire experiment setup. So we have already talked about it, that you will be placing the jockey on the left side on the wire. The galvanometer deflection should go onto the right end and vice versa. Your connection should be always neat and clean. So you can use your sandpaper to clear the tip of the connecting wires. The plugs on the known resistance box should be tightly connected. The movement of the jockey should be very gentle. It should not be rubbed or pressed as it may impact the wire. Always remember that one-way key should be inserted when you are taking the readings, or rather I would say when you are performing the experiment. Do not leave the key on the setup when you are not performing anything. The null point what you will be seeing, that is nothing but the null deflection, should always be in the range of 40 to 60 centimeter. Don't see, if you see any kind of loops in the wire, kindly change it. So you should not be having any kind of loops or any kind of tapering on the wire. So you should be remembering all these important tips. This will help you in getting the accurate reading.